alpha is equal to a minus b and beta is equal to b. Okay. Okay. So a minus b, right, plus b, so that it will be a, and then this is just b. Okay, fine. Now so for example, say now the thing is, the dimension which I deal with is like a very large dimension. Okay, so then I would like to know what is the linear combination of a particular function. Okay, then it will be a little difficult, right, in order to calculate alpha and beta. Okay, so what is the linear combination which will achieve the particular vector? Okay, what is the linear combination of the basis so that a particular vector will be achieved? Okay, it will be a little challenging. Okay, but if we choose a basis wisely, then that problem will be easy. Okay, so for example, you choose 1 0 0 1. Okay, and then a and b. What is alpha and what is beta? Alpha is equal to a, beta is equal to b. Okay, now let me alpha into 1 1, maybe 1 by root 2, 1 by root 2 plus beta 1 by root 2 minus 1 by root 2. Again the output is AB. So now what is alpha and beta? Sorry, alpha is a plus b whole root 2. Okay, and beta is alpha is sorry, what is alpha? Root 2 into just b. Okay, is it so? Okay, so before we solve this problem, I want you guys to check about the orthogonality between this vector and this vector. What is u dot v? 0, which means they are orthogonal. It's not just orthogonal. What about u dot u and v dot v? U dot u is 1, v dot v is 1. Okay, so it's been normalized yeah, with respect to the magnitude. So it's been called orthonormal basis. So if I consider this u and v are the basis, then it's a special basis, orthonormal basis, not a unique one. There can be many orthonormal bases. For example, this is also one of the orthonormal bases. Okay, and this is another orthonormal basis. So what is the advantage of having an orthonormal basis? Okay, so the advantage is calculating the alpha and beta is very easy. So what's alpha? In this case, let's say this is, let's say, w. Okay, so alpha is nothing but u dot w, and beta is nothing but v dot w. You could check. So tell me, what is u dot w?
A by root.
Is it just a by root 2? u w.
A by root 2 plus A plus B by root 2.
So a plus b divided by root 2, right? And beta is
A minus B by root 2.
a minus b by root 2. Okay, you could put here and you can check. So you're getting right. Okay, so that's the advantage of having an orthonormal basis. Okay, so now okay, that's fine with the vector. So how that can be used in a let's say the function space. Okay, say I do not know a function, okay, which I would like to know, but I have a basis. Let's say I have a basis. Okay, um, let's say the basis is 1 comma x, x square, x cube, dot dot dot. Okay, so I do not know the function, some polynomial which I do not know, but the thing is I could represent that polynomial as a linear combination of these functions, these basis functions. Okay, so now all I have to worry about is what is the coefficient. Let's say I have a function. Okay, the function which I would like to calculate is valid in an interval of uh, let's say 0 to 1. Okay, so if I have the interval 0 to 1 and I want to know uh, what is the what is the coefficient if I use this one. Okay, but the problem is, if they are orthonormal basis, then it is easy for me to calculate the coefficient, but they are not, right? So for example, are they, we didn't prove that they are not, but are they orthonormal? So what do you have to do? So you have, say for example, you have to check whether this and this are orthonormal. Okay, whether this and this are orthonormal, like that you have to check, and also you have to check whether this and this are orthonormal, whether this and this are orthonormal, like that all combination needs to be checked. Okay, yeah. Okay, so now we will discuss another example where um, that is being used, which is Fourier series. Do you guys know what is a Fourier series? what it is?
Of x is equal to a naught plus bn.
Right. So, where do we use this Fourier series? So, what is Fourier series? I mean, that's a formula, but what is Fourier series?
It's an approximation.
Approximation of?
An integral.
No. What it is?
We'll convert some functions into sine and cos functions.
Right, but you said some functions. What kind of functions? Whether any function or some special functions?
Non-repeated, like
Non-repeated.
that means non-cyclic.
No, but something to do with that repetition. What it is? So if a function is a periodic, okay, it's repeating. Okay, if a function is periodic, then we could represent that function as a linear combinations of sines and cosines. Okay, so say for example, f of x is equal to f of x plus, let's say in this, okay, in this equation, the period is 2 pi. Okay, so you have a function like this. Now the f of x can be written as um, linear combination of, let's say, summation uh, an cos nx plus summation bn sin nx. Okay, so here what we have done is we are writing the function f of x, a periodic function, as a linear combination of these cos nx and sin x, where n could be any integer, right? Okay, where n goes from here 0 to infinity, and here n goes from 1 to infinity, right? Because sine of 0 is 0, right? So that will not contribute. Okay, now the challenge is, how do they calculate this an and bn? So they are writing that as a linear combination, but yeah. So before that, we need to check this basis set. What is the basis set? The basis set contains sin x, sin 2x, sin 3x, sin 4x, all sin x, sin nx, and then cos x,
And cos 2x,
cos 2x, cos 3x, all those things. And also 1. 1 is also another function. Are they orthonormal in the interval of 0 to 2 pi or minus pi to pi?
0 to 0 to 2 pi.
0 to 2 pi or minus pi to pi, any interval with the
That means cos x and sin x, those two functions, or else
so sin nx or into sin mx integral, let's say minus pi to pi. Okay, dx. What is this? Or maybe for a simple case, um, sin x cos x. What you're getting? So it's 0. Okay, so you could also see that through a graphical representation. So if you see between minus pi to pi, uh, sin x is going like this, right? And then cos x is kinda going something like this, right? Right. So now if you see, say between 0 to pi by 2, the contribution is positive for the integration. Okay, and from pi by 2 to pi, the contribution is negative, but the thing is same. Say for example, so at this point, this into this is same as at this point, this into this, right? So those two contributions are getting cancelled. Similarly here also you could see the contributions are getting cancelled, and you could see like that for any sin x and cos x, or also any cos x and sin, cos mx something. Okay, okay, now tell me, but now we can see that it is orthogonal, but are they orthonormal? What is orthonormal? The magnitude has to be 1. Okay, so integral minus pi to pi sin x into sin x itself dx is what? See, sin x into sin x is sin square x. Sin square x can be written as
minus cos 2x by
1 by 2 minus
cos 2x by 2.
2x by 2. Okay, dx. So for 1 by 2, what you will get?
1 by 2x.
So x by 2 minus pi to pi, and what is the answer for that?
0.
0.
No, sir. Pi by 2 plus pi by 2. Pi.
So it's pi. Okay. So the contribution from the first term is pi. What about the contribution from the second term? Cos 2x by 2
1 by 4
minus
sin
cos 2x by 2
minus 1 by 4 sin 2x.
minus 1 by 4
Sin 2x
sin 2x
dx.
minus pi to pi. Okay. So that is minus 1 by 4.
Sin 2 pi plus sin 2 pi. 2
So,
sin 2 pi.
okay. So 2 pi, sin 2 pi is?
Sin 2 pi is 1.
No,
0.
0. So sine of minus 2 pi?
0.
0. So
0.
0 minus 0, which is 0. So the answer is just pi. Right? So what you have to do is, in order to make the basis orthonormal, you need to divide that by pi, or you just calculate the coefficient and then divide that coefficient by pi. Okay, so it is not just true for sine and sine. You could also try for sine 2x and sine 2x, or sine x or cos 2x and cos 2x, anything. Okay, so it will always be pi. Okay, so now if you see uh, the way the coefficients are being calculated for a naught, which is integral minus pi to pi. So there f of x is that just whatever that periodic function we need to calculate, and the other the function from the basis, the orthogonal basis, is just 1. Okay, so which is dx, and we know that in order to normalize, it's not just 1, it's pi, so we are dividing by pi. Okay, so that's the coefficient for a to calculate a naught. Okay, and then if you see an 1 by pi integral minus pi to pi f of x, is it cos? Okay, cos n of x dx. Okay, so it's nothing but we are doing an inner product. Okay, and similarly for bn, which is equal to 1 by pi integral minus pi to pi f of x sin nx dx. Okay, so that's what the Fourier series. So Fourier series can be seen from a linear algebra perspective. Okay.